the lines, there are three different scenarios. First is that the pair of lines will intersect at a single point like this. Second, they're parallel, so they don't ever touch each other. And we just talked about equivalent linear equations. So they may look different, but they actually end up being the same graph. So they basically are on top of each other. Or we can also think of them as intersecting at infinite points, at every single point on the line. So there's this one single point of intersection. Okay, and this is no point of intersection. And this is, we say it's infinite point of intersection. Okay. All right, so let's do an example here. Y is equal to x minus 1, right? And y is equal to minus half of x plus 2. So if two equations are given in the y slope y-intercept form, that's the easiest one you can do, because it's y is already isolated for you. So all you have to do is make the x minus 1, the x parts, equal to the x parts. Okay, I'm going to multiply everything by 2 to get 2x minus 2 is equal to minus x plus 4. Add both sides by x and you get 3x minus 2 is equal to 4. So you get that, and x is equal to 2. You plug that into this equation, you get y is equal to 1. The point of intersection is 2, 1. Okay, so that falls in the first category. Okay, so let's do another example with a different set of equations. Okay, this time, not so neat like that. I'm going to give it to you in different, this is a general form. So 2x minus 2y minus 2 is equal to 0. And 2y plus x is equal to 4. What's the point of intersection? Okay, so for this, I'm going to use a substitution method. Okay, so I'm going to call this equation 1 and equation 2. From equation 2, I'm going to isolate the x. You get 4 minus 2y. And I isolate the x, but that's the easiest thing to isolate. I'm going to call this 2 prime. I'm going to do this 2 prime, sub into equation 1. So you get 2. The x gets replaced with 4 minus 2y minus 2y minus 2 is equal to 0. 8 minus 4y minus 2y minus 2 is equal to 0. So you get 6 minus 6y is equal to 0. Minus 6y is then negative 6, so y is 1. Okay. So if you plug that in here, x is equal to 4 minus 2 times 1, so you get 2. This is the answer. It's exactly the same answer. Okay. So if we actually simplify this to the y-intercept form, we would have noticed that this is the exact same question. Okay. Equations that give you the same intersection point like this is called equivalent linear system. Okay, so we call this a linear system. So if they're the same, we call that an equivalent linear system.